Hi, my name's Emily. Today I'm going to talk to you about Group 6's swim lane diagram. I wrote the biography, did some of the diagram, thought problems, solutions, and contributed to video discussions. Lucy did a lot of the swim lane diagram, and I would just like to acknowledge her hard work. Our disease is multiple sclerosis. This is an autoimmune demyelinating disease whereby the myelin sheath, the fatty sheath around neuronal axons, is degraded. So the action potentials, the electrical signals, which means that neurons talk to each other and basically don't pass along the axon. So you get these distorted messages, and depending where the lesion is, you get symptoms. So things like sensory and motor impairments. You can have problems with coordination, bladder problems, and fatigue. 2.5 million people live with the MS worldwide, and the UK stats pretty much reflect what goes on globally. So average age of onset is about 30, most patients are women, and also it's characterised by this symptomatic asymptomatic pattern, which is where we meet Suzanne. She is a married woman in her 30s. She, after the birth of her son, she felt very tired, she didn't think anything of it. In her late 20s, she had an attack, her first attack, which was blurry vision. Eventually, it kind of came and went. She went to the optician, said, hey, you've got inflammation of the optic nerve and you have optic neuritis. So he said, go to the GP. And he referred her to the neurologist and gave her examinations, blood tests and MRI, and 6 months later, she's diagnosed with MS. And this is where we sort of meet Suzanne in our pathway. So these are just the actors very quickly. It comprise of smaller organisations, optician, GP, the hospital is made up of smaller departments, neurology, radiology, for example, and then these smaller sort of regional systems like the neurophysiologist. I won't talk about these today, they are in our diagram, but just to say that because they are regional systems, they may be vulnerable to data governance and data sharing problems. So each organisation follows a similar paradigm. Susan should go to she'd book an appointment through e-booking or a secretary calling them, and then meet with the medical professional who interacts with their own sort of data island and IT infrastructure and would update this electronic patient record, which I will call EPR. GP, same paradigm, but the only thing is they interact with the hospital through NHS Digital, and within the sort of subsystems of the hospital, again, same paradigm, but you may have sort of specialised equipment or a TIE, which is this translation interface engine, which means that all these different systems can talk to each other via HL7 messages because they're translated by the TIE, which I'll just call TIE. Okay, so this is our swim lane diagram. It is humongous. And our actors are along the top, and down the side is everything happening in chronological order. So it's very sort of common sensey. So the events are in a box, and various different things like if we send a letter, envelope, paper-based reports, written in paper thing. Arrow is direction of flow of HL7 messages, and we've always done an acknowledgement message by the dashed line. I won't talk about that again. And so the bottlenecks and problems are denoted in colour boxes and solutions in the corresponding colour in a speech bubble. Interoperability and feasibility is denoted by the Straffer-like system. Green, pretty obvious. Medium, data sharing is kind of needs mainly manual intervention, and there's some loss of sort of or duplication of information and delays. And no interoperability means no information flow, high risk, high governance, huge delays, and just rubbish. So this is the first part of the diagram. This is basically what I engineered along with the pharmacist. So along the top, patient, optician, secretary, the optician himself, and they each have a sort of data island, GP, secretary, GP data island. So what I'm going to do is talk through this, but for the rest of it, I am going to just pick out the problems and then solutions, because there's so much to get through that I am already talking at 100 miles an hour. So here's our poor old Suzanne. She's got intermittent blurry vision. She makes an appointment on an app, and I'll just say we are using HL7, and each message has its own code. So SRU would be scheduling information, ADT would be admission. Whenever an EPR is updated, we put MDM, which is medical document management, and if we order something, like a lab test, so that's that done. Okay, so she goes to the receptionist. Receptionist updates her EPR. So yes, she's checked in. She goes and has examination with the optician. He is using this imaging software and its own storage. Yes, she has optic neuritis. She needs to go to the doctor fast. He gives her a report. Also updates their private EPR, and this may actually cause a little bit of problems potentially, because the images would have to be updated to her EPR but aren't necessarily directly connected electronically. So then he would email the patient report to the secretary, who would then print it off, give it to the patient. Anything that's in paper form is a potential hazard for blocking information flow. So here we have amber. And then, so the patient can then take it to the GP and say, hey, I've got this optic neuritis. So the biggest problem in this pathway is that actually getting an appointment at the GP. We've all been there, phoning, can't get through. Eventually she does get through. She turns up. Again, her EPR is updated when she sees the GP. He suspects that she has MS, but can only say she has a demyelinating disease. One source of problems could be that they use the read codes. I put that they haven't. They've used SNOMED. And actually for MS, the SNOMED codes are pretty limited, but it's very broad DMD, which demyelinating disease. So that would perhaps be a problem. So then he creates a prescription for her to help her with her inflammation, and he prints it off. So again, that's paper, and there is, there's this, hybrid system of paper and electronic systems. And then the GP would refer her to the neurologist. And this would be a green light for interoperability, because they're using the NHS digital e-referral system. So the biggest problem here really is that she's using a private system and integrating it with the NHS. So this is a massive data island. So one solution would be to use a health information exchange, which could be a centralized model where information is sent to a central clinical data repository from remote sort of feeder systems, which I got that sort of information from the Guide to Health Informatics textbook. And you could use a cloud-based system if you were using API and the FHIR system, which I'll talk about later. Obviously, another thing to worry about is privacy and security, and you'd have to use gateways, firewalls, and also perhaps use electronic consent systems at the GP, see who has full partial access to her records. And to help her actually make an appointment, you could use an app, use a scheduling app, which would have real-time information and perhaps would free up the secretary so she could actually answer the phone, which yes, I get very frustrated by. So when you're at the pharmacist, you're using these hybrid systems, and I think a reluctance to move over, particularly by the NHS, is that it's very expensive, because you have to employ these specialist testers and see if it's user-friendly. But actually, I do think that the NHS uses electronic prescription service. Another way to do it, particularly if you're at the pharmacy, just because she may have failed to mention that she was allergic to something. The pharmacist could use a digital dashboard, so you could view all the patient's information, see who's risk of medication errors, and you could take action there and then. And also just to say that with the HL7 messages, we have included a billing database, which isn't necessarily so pertinent in the NHS with regards to patients anyway. So here, she's gone to the referral's gone to neurology secretary, and the GP letter and the patient record is received and printed. And so this would have to then be uploaded to their system, which again is paper, so potential problem. And so one good thing about the hospital is the use of this TIE, so that's a green light for interoperability. But you know, different systems even would use different types of you know, documentation, etc., etc. And one way to get around this would be to use OpenAIRE, which has all this uses these templates and archetypes. And that would just be one way that different systems could communicate with each other and just update one electronic health record. And also, really, I think on that video that we watched, you know, doctors seem to have warning fatigue, and so you know, if there are warnings coming up with these neurological examinations, have you done X, Y, and Z, perhaps sort of work on that and have more user-friendly systems. And so this now is just showing the radiology department and the lab. So she would, you know, have to go for an MRI test. And so, you know, again, it has its own sort of little data island communicating with the TIE, and they would use specialist software which would have its own imaging software and own sort of archive, and then the diagnosis would have to be dictated. And so you would have sort of problems like variation in the type of software, classic grammar, so if it's being, you know, dictated, perhaps the secretaries don't understand you know, what the clinicians mean. You know, you would have a computer to human interaction, so the staff would have to be trained. There is a heavy reliance on IT infrastructure, there's the use of different systems, legacy systems. Again, there's a data silico within a system, perhaps, you know, archiving sort of physical imaging files. You know, again, there's an issue with security, and you know, there's old, you know, inadequate IT infrastructure. You know, systems crash, need updating. The TIE would need updating, and so you could use this HL7 FHIR API-based system, which is everything is over the internet, which means you could use platforms like SMART, which allows different software to be functionally interoperable. You could what else could you do? You could password protect everything, perhaps invest in more suitable infrastructure with the IT, i.e., you know, train them better, and make sure that it's less buggy or robust operating system, with fewer sort of upgrades each year. And you know, by using things like OpenAIRE or SMART, everything is very adaptable. And it ensures that the software would be, you know, you could easily upgrade it. And so just going through this, yeah, and I don't think I've really got anything else to say. I think that's pretty much covered everything. So thank you very much.